Anyway, go on.
Yeah. I'm Ayumi Fujisaki-Manome. I am an associate research scientist at University of Michigan's Cooperative Institute for Great Lakes Research. I do research about lake ice, sea ice, and hydrodynamics. I'm originally from Japan. I think I got interested in earth science when I saw one of the first kind of live stream from Antarctica. That was very cool. And I was very impressed and amazed by the cool science people do in a very harsh environment. I continue to do research on lake ice and understanding hydrodynamics, lake circulation, and lake temperature that impacts lake ice. Untangling the contribution of each is a big challenge. And that's one of the big research questions we are trying to address. Primarily using computer simulations or numerical model. I also try to understand what's driving change in lake ice, how that is impacted by climate change. In the long term, we are seeing declining trend of lake ice cover, and in the past 2 winters, we had near record low ice cover in the Great Lakes, and that was a scary trend.
On Lake Michigan this winter, according to NOAA, ice coverage over the 5 Great Lakes was just 6% last month. That's one of the lowest levels on record, thanks to our warmer than average temperatures. This could have a big impact on the environment. Years with low ice levels can lead to higher evaporation rates, which can mean lower water levels and more stress for the ecosystem.
And this year, definitely one of those record years where we're seeing a low ice coverage all across the Great Lakes.
The lowest on record for this point in the winter since 1973.
A lot of data we are looking at only goes back to 1970s, which is when a lot of routine satellite measurements started. That record is not long enough. We still don't have a very good understanding of what's the contribution, like how much global warming is contributing to ice loss. We don't have long enough record to understand exactly what's the contribution of global warming versus what's the contribution of natural variability. We need much longer data. So we wanted to understand what's the contribution of global warming and what's the contribution from natural variability. So I recently reconstructed daily air temperature record dating back to 1890s. And in the near term, I am very much interested in what we see in that data, how that translates into ice conditions, and just to ensure what we do is helpful and innovative enough to advance prediction capability to the next level.